Welcome everybody to this Lightboard session on vSAN. The specific topic we're going to look at in this session is storage reclamation. What is it and how does it work in vSAN and how can it actually help you?
So the origin of this conversation with most customer and storage administrators comes from looking at some tools that are looking at the guest operating system often within the virtual machines while thin provisioning is in use. And thin provisioning is a great technology. You know, if I allocate 100 gigabytes, but I only write 20 gigabytes of data, it's a 5x savings. You know, it just saved a lot of space. And this was one of the first great use cases, frankly, for vSphere in the early days, was being able to thin provision and overcommit back in storage. And vSAN, to a degree, makes this even easier because it's one large pool rather than having to manage a bunch of tiny islands like we did with VMFS. Now, there are some kind of details that have to be involved with thin provisioning, and one of the unfortunate things that people may not be aware of is that a lot of file systems like NTFS, XFS, ext4, they by default will write into free space. And so even if you delete data, they won't go back and reuse those same blocks. And so they'll just slowly keep using more data. And by default, the vSphere layer is unaware that those blocks are no longer in use. So if you delete something, by default, it wouldn't necessarily have awareness. So this is where these commands, this trim and unmap, trim being the ATA command set, unmap being the SCSI version, and deallocate being the NVMe version, these come in and these allow the operating system to tell the vSphere layer, data has been deleted. I no longer leave these blocks. You can reallocate them for other use. And this is something that does require specific operating system versions. This does require, within Windows 2012 and on, it's enabled by default, but within Linux, you'll have to configure something like fstrim. But this can get you a lot of space back. We've talked to customers who at scale were missing a petabyte of storage. It's not uncommon to see, 20, 25, 30% of your space come back in a mature environment that's been deployed for a while. And this will help you get that space back, get more TCO out of your environment.
One of the other things that we see that is interesting there is that trim unmap can help you more accurately understand how much storage capacity you are using within the VMs that are running in that environment. What can happen with your VM workloads is there can be that natural slow erosion of what is seen as a perceived capacity consumed, yet the operating system may be performing some activities that it just temporarily used some of that storage capacity and is no longer using it. But you're looking at the used capacity and it just sort of keeps on growing. And that, from a reporting standpoint, that can be a little bit misleading. So now that we can honor these this reclamation request through trim and unmap, it's going to send that down through the stack and reduce what is seen as the effective used space for that. So it's going to free those previously used blocks so that they can be used for other things.
No, I mean, what's better than getting more free space to use? So
it's a great point. No. All right. If you'd like to learn more about trim unmap and the all things about space efficiency, there is a great paper out on core.vmware.com focusing on these space efficiencies capabilities, and that is going to go into detail what trim and unmap is and a variety of the other space efficiency options that we have. Thank you very much.